Okay, then let's get started on the crunch review of probability theory. So the organization is as follows. Okay, it's not the same order as in the textbook. So we are going to review chapter 1 to 3. This is a self-study, and then we're going to get into the exponential Poisson process, Bernoulli process, and then DTMC, CTMC. So, and then the last renewal theory and the Markov decision process. So in the very beginning is chapter 1 to 3. Okay, it's a review. I assume in the master you have already learned some of this probability theory. So most of my notes are published in the Canvas. Again, this is a required class for PhD candidacy. I hope to build a very rigor and strong foundation for you guys for the PhD study. Also, stochastics is so important for IE. So this is a very important class in IE. I hope you guys really have a very good knowledge about stochastics. So I'm going to go from probability theory to different kind of DTMC, CTMC to build a very strong foundations, so that later, if you want to pursue advanced topics in stochastic modeling of the manufacturing system, healthcare, or decision making, you can have a very powerful tool in hand, okay, to tackle all these research problems. Okay. Is it cold here?
For me, yes. A little bit.
You're close to the heater.
Yeah, I'm kind of sick.
Yeah. Take good care. It's a okay. Now the first problem we're going to talk about is the one problem called St. Petersburg paradox. So here is it. No. This is self-study, and then second is the St. Petersburg paradox. What is St. Petersburg paradox? It's a fair coin. It's tossed repeatedly. You just toss a coin until it shows heads. Okay? Because when you toss the coin, you will show tail, 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 and the head, right? Or you show head directly. Or you show tail, head. And the casino agrees. Now you're going to play a game against the casino, okay? Casino agrees to pay the gambler $2 if a head appears on toss 1. $4 if the first head, you must have tail, 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 and the head, right? If the head show up on toss 2, you get $4. $8 if show up in toss 3, 2 power k. So if you show up in the 10th time, you're going to have $1,024, 2 power 10. So now, 2 questions. What is the gambler's expected reward? How much will you pay to enter this game? Okay, how much are you going to pay to enter this game? Think about this. You see, play head, right? Pretty good. If I'm lucky, it's 10th time the head come up, I get $1,000. How much are you willing to pay? Any idea? Willing to pay? I mean, there's no nothing that is has to be certain. I just try to check. But this is an old problem, and it's in the history. It started from early 1700. It's 1700 years ago. It's from Nicholas Bernoulli formulated this problem, and they're going to ask different kind of mathematicians on how much are you willing to pay. Okay, some say $24. Some say maybe $10. Some say I'm willing to pay $1,000. Why not? I mean, just play many times. I'm going to get sometimes I may get 20, right? 2 power 20. That's a lot, right? Yeah. But what is a paradox? Paradox is actually nobody is willing to pay a lot of money to play this game. Because you may say, oh, it might come up just in the first one. I just get $2. You wanted me to pay $1,000 for it, right? So low gambler will agree to pay an infinite entrance fee in reality. Okay, most of them maybe pay maybe less than $25 to play. Okay, but how to solve this paradox? Okay, what is the paradox? The expected reward. What is the expected reward? You see, what is the expected reward? So this is what is the probability to have head appear in toss 1? 0.5. What is the second one?
0.25.
Yeah. Right? Okay? And this is the probability that the head appears on toss 1, toss 2, toss 3, or toss K. What is the expected reward? Is 2 by 1 over 2 plus 2 by 1 over 4 plus 2/3, 1 over 2/3 plus K, 2 power K over 1 power 2K. So now if you check the limit, if you add them together, if you take the limit, K goes to infinity, what is the expected reward? Infinity. That means if you play this game, on average, you're going to get infinity reward. That means you're going to earn a lot of money as long as you have a lot of money on your back so that you can play this game. Okay. So, but most of the gamblers, if they are rational enough, they don't want to pay infinity money to play this game. Okay. So this is a paradox. So the reward you're going to get is infinity, but you only want to pay maybe a small amount of money to play this game. So this is a paradox. And Nicholas Bernoulli tried to formulate this problem, and then he's going to study how to solve this paradox. And this is going to be discussed in Thursday. Okay, if you are interested in this one. Okay.